Let's answer some questions about continuity by looking at a graph of a function. So this is the graph of this piecewise function. And we're going to answer some questions about it. Well, first of all, the first question is, does f of minus 1 exist? So, well, let's look at x equals minus 1. And yeah, I'd say it's right there. Sure, that exists. Next question is, does the limit as x approaches minus 1, negative 1 from the positive side exist? So I'm coming towards x equals minus 1 from the positive side. Does the limit exist? Yes, certainly it exists. It's that point right there. It's 0. The next question is, this is a yes. Does the limit as x approaches 1 from the negative 1 from the positive side equal f of negative 1? Well, yes, it does. They're the exact same. The limit is 0. So is f continuous at x equals negative 1? The answer is yes. Now, you got to think about this for a minute. The answer is yes because this right here is an endpoint. There is nothing coming on the function from the other side, so we consider this to be continuous because it is an endpoint. Normally, you have to have the limit as x approaches c of f of x equal f of c. But in this case, this would require a two-sided limit because it is an endpoint, we have a special rule that says, well, since it's a left endpoint, it only has to be continuous as it's approaching it from the positive side. Let's look at another set of questions. Same graph, same function. Does f of 1 exist? Well, here's x equals 1. Yes, right there is f of 1. Does the limit as x approaches 1 of f of x exist? Well, I'm going to follow my function here as x approaches 1. Do I have a limit? Yes, I do have a limit. That limit, yes, the answer to this is yes, answer to this, and the answer to this is it equals 2. That's the y value right here as x approaches 1. Does the limit as x approaches 1 of f of x equal f of 1? No, it doesn't. Because f of 1 is 1, and the limit as x approaches 1 is 2. And that's actually the fact that it approaches from either side, because it's a limit, so it comes from both sides. So is f continuous at x equals 1? No, it is not continuous at x equals 1. Another question, is my function defined at x equals 2? Well, I don't think so. That's an open circle there. So it is not defined at x equals 2. So, is it continuous at x equals 2? Well, here's the definition of a continuous phi. The limit as x approaches c of f of x equals f of c. So if I was to say the limit as x approaches 2, does that equal f of 2? Well, no, it does not, because there is no f of 2. F of 2 is undefined. So, no, it is not defined there. So, no, it cannot be continuous there. Can I make the function be continuous at x equals 2? Yes, I can. If I define f of 2 to equal 0, I add that definition to the function here. If I did that, then I would have a closed circle right there, and my function would now be continuous at that spot. And similarly, if I redefine f of 1, right now f of 1 is equal to 1, but if I change that and I redefine f of 1 to be equal to 2, then this point here would move up to there, and that would make it continuous at f of 2. So these are both removable discontinuities that we just talked about.